Good morning, students. Hope all are safe in your home. Okay. Last class we discussed the major concepts of file handling, that is absolute path, relative path, and some of the programs related to read and write methods. Okay. 4 programs we discussed previous class. And before class we discussed modes of operations on files, binary files, and data files, that is text files. All these concepts are over. Today we conclude this chapter. Okay. Today we discuss the significance of the file pointer, that is also file pointer is calling it as file handler, file object, file reference. All these are same meaning, okay, same definition. So what is meant by file pointer? What is the purpose of the file pointer? What is the functionality of the file pointer? Okay, so file pointer, when we open a file, okay, must and should every file maintains a file pointer. Suppose I am creating a file. Okay, this one is a file which consists of welcome. Okay, automatically when you open a file, one file pointer created. That refers to the address of the file, starting a beginning address of the file when you open read and write methods. Okay, when you open for read and write modes. Okay, suppose every file in every file maintains a file pointer. When we open any file in write mode or append mode or read mode, first it creates a file pointer. Next, coming to second point. So file pointer tells, the purpose of the file pointer is it tells the current position, the file where writing or reading takes place. Suppose I am writing new data in append mode. Okay, the presently file pointer points to here, for example. Then I am writing here. So I am writing new data on this current position of the file pointer. So every time file pointer moves from starting byte to or starting character to right side, left to right side. Okay, and every line ends with a new lines, and every line ends with a new line character, new line or end of line, new line or end of line, /n or EOF. These are end of line. So FE tells the current position in the file where writing or reading, okay, takes place. Where you are writing, where you are, from where you are reading the data, that can be displayed, tells the file pointer. Okay, next coming to when we read from the file, suppose we are reading from the file or writing onto the file, two things happen. So file pointer is used for mainly two purposes. One is for this operation takes place at the position of the file pointer. It specifies it represents the position of the file pointer where we are writing, where we are reading from the file, or where we are writing onto the file. This is the first operation it specifies. Second one, one more advantage of file pointer or significance of the file pointer, by specified number of lines. We can specify number of lines or bytes. So this can be explained with example. Second point can be explained by using the example. Suppose I am creating one file. So that file consists of welcome to GFSI. So one file consists of this data, welcome to GFSI, WELCOME, welcome to GFSI, GFSI. Here new line character, new line, it is not displayed but we are expecting new line character. Welcome to GFSI. So this can be right by using, okay, second thing, file pointer advantage by the specified number of lines. So when you open this file, when we open this file in read mode, file pointer FP, okay, is created. Open this file, okay, myfile.txt, comma read mode. I am opening this file in read mode. Okay, when you open this myfile.txt in read mode, always read mode file pointer. When you open this file pointer specifies the first character of the file. So okay, I am reading data from this file. The position of the where it is located, it displays the first character, that is W. Then I am reading data. So str is equal to, okay, read fp.read. I am writing one code here. str is a variable. Okay, so by using this file pointer, you read data from this file. This one is myfile.txt file. So I am reading this data from this file. So str is consists of, you are reading on data, so that W is stored in str. Then you print str. So it displays the print str, it displays W on the output screen. In the output screen, it displays output screen W. Suppose next time I am writing, one more time I am writing str is equal to fp dot one more time read. So next fp moves to second character. This time, okay, myfile.txt displays E, str displays E. After that L, after that C, after that O, like that it displays character by character. So file pointer moves character by character or byte by byte every time when you are read. So read method is used to move the file pointer one byte or one character at a time. Okay, this is the concept. Okay, next, suppose when you are using, okay, second one, when you are opening this file fp, okay, ch str is equal to, okay, open, sorry, fp is equal to open myfile.txt, comma read mode, okay, then str is equal to, okay, read fp dot read off 1. I am specifying here 1. 1 means here 1 byte. 1 means here 1 byte. See here, this file consists of welcome to, yes, welcome to GFSI. I am writing fp is equal to open of myfile.txt in read mode, str is equal to fp dot read, and print str. I am specifying print str. Here this time I am specifying here read of 1. Read of 1 means 1 byte. Here we read 1 byte by using file pointer. 1 byte at a time. So 1 byte means first byte. When you are opening read mode, fp, okay, position the location and specifies the W character. You are asking only 1 byte. Read 1 byte from the myfile.txt. That's why it displays the str contains w. Okay. Next time I am specifying, okay, str is equal to fp dot read of 3. Already fp position in first character and print that first character w. Store w and print that output screen w. Okay. Next I am asking one more time, str is equal to fp dot read of 3. Here 3 bytes. 3 bytes. Okay, read from the file. 3 bytes, you are specifying number of bytes. You are specifying number of bytes. 3 bytes read from this file. 3 bytes means already fp is present in this w. So from next onwards 3 bytes, that means e l c. It reads these 3 characters and file pointer positions after reading these 3 values. Okay, these 3 characters file point represent O. So str, this time str contains E, L, C, 3 bytes. Already fp return this W. That's why it return E, 3 bytes, 3 characters, 1, 2, 3, these 3 characters. So next fp represents current position to O. In this way you specify, okay, without specifying read means at a time one character. With specify read method with one argument, that is n, means n bytes you are reading from that file pointer position. Okay, suppose if you are specify read of 5 means 5 bytes from where the file pointer is positioned to 5 bytes. So it advances or move 5 bytes forward and store it in str variable. Then you print str. Print str means it prints the value of ELC. Okay, this is the concept. Next, in this way file pointer can be used. So you can get data from the file by using the file pointer when you are using read or write. Okay, suppose you are specifying write of 4. So you are writing, you are preparing for 4 characters to write, 4 bytes to write on that file. Okay, this is the concept of significance of file pointer when you are using files. The plus function, okay, is a function which is used mainly for when you are writing any data onto a file. This function is useful in that situation. So every file, when you are writing some data, suppose I am opening one file, okay, welcome. Okay, so when I am opening one file, first when you write data, not directly write that data onto that file. Every file uses some private memory location. That memory is calling it as buffer. It uses some buffer area, buffer storage. That means memory, private memory. Buffer means private memory. So buffer means it is a temporary or private memory of the file. First when you write some data, when you open a file, one buffer or private space created for that file. Okay, after that you write data, suppose welcome not directly write onto the file. First it write onto the buffer memory space. From that buffer to main memory, that is where the secondary file is stored in secondary memory, that can be transferred from buffer to main memory. For example, in real life, when I am giving one problem, mathematical problem, so then you solve that mathematical problem not directly in your classwork. First you calculate or process that mathematical problem in your rough book, okay, rough work. After, okay, processing completed and finishes the problem, and if it is correct, then you write or copy that rough work computational steps onto that your classwork. So like that here also. So first you use for computation purpose, you are using not directly in your classwork. First you write down or process entire all the steps of the problem in your rough work. If it is right, then you write all the steps of the problem onto the classwork. Like that here also, every file, when you are writing some data onto that file, first not directly write on that file. First it directly write onto the buffer area. Suppose first when you write something by using file pointer fp dot write, here I am writing fp dot write method. So fp dot write of hi, I am writing here hi, okay, fb dot write of hi. So hi can be first write down in, I'm by using keyboard I am writing this one into, when it reads and store it in buffer. After that by using file pointer it can be placed in, stored in my file.txt file. In this way, first entire data write onto this buffer, after that it's stored in file. In some situations, okay, suppose you are writing hi, after that welcome, after that I am writing welcome. So this hi can be write down in file from buffer to file location, but welcome is after that, in that hi is deleted. Here welcome is placed in buffer. Meanwhile, some technical issue or power failure, okay, some technical issue or power failure, the data not write onto that your file. So the data that is welcome is stored in buffer, not write onto that file. So in this case, so already file closed. When power, okay, failure or any technical problem arises, file closed, okay, file closed, automatically file closed. In that situation, already high data is write onto that file, but welcome data not write on from buffer to file. So you lose your data. In that situation, so when you are not closing that file, but some technical issues or power failure problem arises, automatically file closed, your system off, that's why file closed. In that situation, some data reside in buffer, that buffer data not write onto that your target file. So you lose your data. So all the data, some data write onto that file, but some data not write onto your target file, but it is placed in your rough work, that is in buffer. So in this situations, this function, plus function, used for this overcome this situation. So flush function is used, forces the writing of data on disk still pending in output buffer. So from buffer to remaining data are placed in buffer. So you are forcefully write data from buffer to file by using this method, that is flush function. So flush function is syntax is file pointer. Already you are opening for either read mode or write mode. One file pointer created and you write data. Okay, that data is already present in buffer, but not stored in from buffer to file. So you forcefully store from buffer to your target file. So by using file pointer object dot flush method, automatically when you apply flush method, it automatically the remaining data that are stored in that buffer automatically write onto that your target file. So for example, here I am explaining this concept. F is equal to open myfile.det file. So det file means myfile.details file with I am opening this file in write mode, write only mode. Okay, write and read mode. Okay, f dot write welcome to. First I am writing welcome to. First this welcome to message, okay, is transferred to buffer. From buffer to your target file, myfile.det file. After that, I am writing one more write method, f dot write gfsi. So here gfsi is stored in. So already buffer stores welcome to message. After that I am writing gfsi. This time gfsi is also stored in buffer. So in buffer welcome to message is stored and gfsi message is stored. These two, okay, contents are stored in present in buffer, that is buffer memory. So these buffer memory, okay, forcefully store onto that your target file, that is myfile.det by using the f dot flush. Here f is a file pointer, that's why f dot flush. Then immediately these two contents that are stored in buffer memory are stored to from transfer from buffer to, that is your target file, that is stored in secondary storage device. Okay, so in this way flush function can be used in real life. So when you are closing any file without specifying close option, okay, this function is useful. So after 3-4 lines you are specifying this f dot flush function up to the data that is stored in buffer file, buffer memory, that can automatically or implicitly, okay, forcefully store onto your target file. So when you are closing, okay, file f dot close, when you are closing a file f dot close, this function automatically, the flush function automatically implemented. That's why when you open any file, okay, after completion of your work, you must close that file. Okay, why? Because if you not close that file, if any data present in buffer, that is not stored onto your target file. Okay, so your writing data only stored in buffer, not write in your target file. So that's why you must close that file with the file pointer fp dot close. When you are applying fp dot close method, immediately flush function applied, and if any data that is present on buffer memory, okay, that can automatically or implicitly or forcefully store it into your target file. After that file pointer disconnected to that file. So you not lose any data when you are writing apply, when you are applying write option. So this is very important when you are dealing with the write operation with files, because when you write something, okay, not directly write onto that file, first it write on like your rough work. So it write on, first it writes on your buffer memory related to that file. Okay, every file consists of some buffer memory. Okay, from that buffer memory to, after that it transfer from that buffer memory, copy from buffer memory to actual target file. So that's why we apply flush function when you are closing. So close function applies automatically or implicitly this flush function. Without closing means you apply flush function by using file pointer forcibly. Removing spaces or tabs or white spaces, that means new line character, spaces, tabs, characters, okay, from both ends. That is, one file consists of welcome to GFSI. Before that welcome, one space is there. Okay. After welcome to GFSI, one space is there. To remove before space, after space. Okay. So that is before space means trailing end. After space, after data means leading end. Both ends. Suppose here I am writing welcome. One file consists of welcome. Here one space is there. Okay. Here also one space is there. To remove this one trailing end, this one leading end. So right side and left side end. So right side and left side end are trailing end or leading end. You remove these spaces when you are reading data from the file. So when you are dealing with reading operation, so to remove before the contents and after the contents or any way, okay, either in right side or in left side or both side. To remove characters, those characters are white spaces or tabs. Tabs means group of characters. Tab means 5 or 8 spaces. Okay, space means single space means one character. Tab means also considered as a character. New line also one character. So all these are called as white spaces. To remove white spaces from both sides, that is right side and left side, that is trailing end and leading end. Okay. So for that removing the process, we use strip method. So this method removes the given character from both ends. So you remove new line character, end of the line. So you give here strip of new line. You specify that character here. That removes, when you are reading that file, fp dot strip of new line. So that new line, when you are reading the data from that file, okay, so new line character deleted and it is stored in one variable. You display that variable, print that variable data. So in this way use strip method. So next, R strip method means, so R means here right end or trailing end. So this removes the given character from the right end of the word or file, or line. Okay, so R strip of new line means here one space is there. You are specifying fp dot R strip of, okay, one space is there. You specify space, single space. So automatically when you are reading data from this file by using file pointer, this cannot be displayed in your variable. Then you print that variable, store it in one variable, then you print that variable. So it is not displayed. This white space is not displayed. Okay. So in this way you remove spaces by using strip methods. L strip means, L means left end. Okay. This removes the given character from the left end of the file or line. Okay. So left end means leading end. This one, here one space is there, new line character or tab or space. You remove this space when you are reading from a file by using file pointer. So you specify fp dot L strip of new line character. Then it removes the character and store it in one variable. You display that variable in your output screen. In this way you use these methods: strip, R strip, L strip. Strip removes both ends. R strip only one side, that is right end, that is trailing end. L strip means left end, that is leading end. In this way we use these functions and we explain this concept with examples here. I am explaining this concept with examples. I am writing one code here. Removing end of line. Removing end of line. EOF stands for end of line. EOL stands for end of line. Okay. Or new line character. New line character. This one is new line character /n. Escape sequences. This one is escape sequences. When you are starting with any character with a slash, that is calling it as escape sequences. One function is applied on that. This one is not displayed, but one function applies. New line character or end of line character. Okay. So this displays next line, end of line, that line completed, next you go for next line. So character from the line, read from the file. Read from the file. This can be explained by using one example. I am creating one file pointer fh. Okay. File open myfile.txt. Open myfile.txt with read mode. Okay, with read mode. Then okay, one variable str is equal to fh dot okay read line, fh dot read line. Okay, so next fh dot read line of this one. So read line one data is stored in this one. So str dot okay r strip of new line character, that is stored in str. Okay, so then you display, see here I am opening one file, suppose myfile.det. This one is myfile.det file. Okay, so this consists of myfile.det welcome to. Here one space is there, for example. Here one space is there. Before welcome and after welcome, one space is there. You read this data from this file by using fh, means file pointer or file handler. Okay, open myfile.txt in read mode. You read data from this file, okay, to one variable str. You create one variable str, fh dot read line. You read one okay line from this file. So welcome to. Here actually it displays welcome to. So this specifies both spaces before that and after that. Okay, when you are reading. So here str is equal to str dot r strip. R strip means new line character. Here this can be r strip means right side end. Okay, not displayed this new line character. Okay, so that removes the character and store it in str. New line, here new line character is there. For example, here new line character. Okay, that new line can be okay removed from this variable. Okay, then you print this variable. It displays only before that. It displays the output. Here one space is there. It displays welcome. Not displays after that any space here. In this way, the three methods r strip, l strip and strip methods are used by using file pointer. So strip method is used for it removes white characters or white spaces on both ends of the when you are reading data from the file. L strip means left hand, R strip means right hand. So these are used by using file pointer. Okay, fp dot. These three methods are used by using fp dot file pointer dot strip. method. You are specifying here which character you remove. Okay, you are specifying which character you are specifying here. So suppose your strip means it removes both ends. Suppose you are specifying fp dot r strip of new line character. So you are specifying which character you must delete from right end. Okay. So otherwise you specify fp dot l strip of new line character. So tab. Suppose you are removing tab /t from left end of the when you are reading data. So where the file pointer location is important here. File pointer only located to some content in the file. From that file content you remove first /t in left side. So in this way these operations are used for removing white spaces. White spaces means blank spaces, or tabs /t, or new line, or /n end of line. So this is the concept. Today we complete this session. So next class we discuss input stream, output stream and error streams, and how they are used in our files handling when you are using file handling. So thank you students.